Welcome all. We're really excited to have you all here today and to have Marty back. We have a repeat presenter this week. This is, for anyone who's never joined us before, one of our weekly OCI deep dives that's hosted on Cloud Customer Connect, which is our Oracle community forum for end users. I'll be dropping some links as we go through today. If you haven't joined that forum, we invite you to come and do that, make a free account, look for upcoming events and more discussions on all kinds of topics. For those of you who have not been here before, my name is Kenna Kettrick. I'm a program manager with the go-to-market team at OCI. And as I mentioned, we have a returning presenter here, Marty Gubar, who is a director of product management for big data here at OCI. Take it away, Marty.
Kenna, I want to go to every single one of those sessions.
Yeah, I'm really excited about that. There's some good stuff coming up.
Awesome.
Oh, good.
So, hi, everybody. My name is Marty, and I am part of the product management team. My partner in crime, Alexi, as Kenna has mentioned, is going to be answering your questions. So just go to that Q&A link, and Alexi is an expert on everything data warehouse and Lakehouse and data lakes and Hadoop and more. So, yeah, I've been here at Oracle for some time, and I'm going to actually talk about some of the things I've actually seen over the years in terms of the evolution of the data warehouse in becoming, frankly, every data warehouse on Oracle Cloud can become a lakehouse. So we will be stepping you through that. Specifically, what we're going to do is, lakehouse may be a new term or a new concept for some of you. So we'll kind of describe what that is. What is a lake house? What do we mean by lake house? How does it compare to a data warehouse and a data lake, etc.? But we're going to focus on a piece of the lake house here, and that is the data warehouse's integration with the data lake, informing that lake house. And what does that really mean? And what are the key things that we've done to try to simplify that integration of the warehouse with the data lake to kind of create a holistic experience for you to be able to analyze all of your data at scale. And I will be going through live demonstrations to show you how a lot of this works. And we'll talk about things kind of that are going on under the covers. So that's the agenda for today. Again, if you have questions, please ask as we go along, and we'll also open it up for questions at the end. So let's start. And frankly, I don't think this is necessarily new, right? This is something that we've been talking about for some time. Get that poll question out of the way. So guys, please, thank you again. There's going to be poll questions coming up. One just popped up in my screen. There's going to be poll questions coming up all throughout. So really want to hear from you. So please answer those questions. And I appreciate you taking the time to do that. So again, using all your data to innovate, it's not a new concept, right? And we've been talking about this for years, right? I mean, like, go back 30 years, right? Not even just with the introduction of the data lake, but the world is becoming more connected, it's becoming more automated, and you really, to drive business value, you need to be able to work with all types of data and ensure that all of it can be available to be used together, to be understood, to understand how to blend data from different sources and be able to analyze all of this information at really large scales. For data warehouse users, right? And I'm trying to remember if we had a poll question to find out how many of you are starting with the data warehouse and moving on to the kind of adding data lakes, or if you're going from the other way around or what. But for data warehouse users, you often need to be able to reach out to other sources to better understand things, right? Like, hey, how does weather impact my supply chain? How do I use IoT data to predict failures of my equipment, right? So this is data that, could be at very large scales, and maybe not appropriate to load into the database. Maybe it's for one-off questions. There's many different use cases, and you just want to easily be able to query that data and analyze that data really from the data warehouse down to the data lake. So make the data lake easily accessible to the data warehouse. And frankly, from the data lake into the data warehouse itself. Like, how do you query the data warehouse at scale from within the data lake, right? So there's all these different things that we want to do to help you innovate and be able to use all of your data. Like I said, this is not, frankly, a new concept. I'm gonna kind of age myself here. So I've been with Oracle since the evolution of the data warehouse, right? So boy, when I joined Oracle, it was one of the Oracle's first acquisitions, frankly, in the mid '90s. And it was Oracle 7.3. That's the release in the mid '90s, and it was a groundbreaking release for Oracle, right? Because that was the first data warehousing release for Oracle, right? So it really introduced the capabilities to analyze data at large scales, and certainly large scales have evolved, right? The meaning of large scales, but at the time, at very, very large scales. And I think importantly, it was becoming accepted that you need to be able to pull data from a variety of sources, put it into a centralized location for analytics. Like, this was actually a good thing to do. And there was always the tension of, hey, I want to analyze data in place on my operational data, or should I actually have a separate environment or that's kind of integrated though, to be able to actually do rich analytics over that information and oftentimes structure the data perhaps in a slightly different way. So, but hey, a centralized source for data is a good thing, right? Well, boy, I'm trying to think now, 10, 15 years ago or so, big data became a big part of the landscape. Actually, that's when I started. I probably started working on Hadoop in about 10 years. Is it 10 years? Probably about 10 years ago now. So Hadoop provided an and I'm going to air quote inexpensive here. You can't see it, but I'm air quoting inexpensive scale out infrastructure that allows you to store data and process that data at massive volumes, right? I'm air quoting inexpensive because, yeah, you could use commodity hardware and you could easily scale, well, again, air quoting, easily scale out the data, but Hadoop, frankly, is pretty complicated, right? It's not the easiest environment to work with. You really needed to be kind of savvy with, like, almost like a programmer, like an analyst. It's not easy for necessarily to manage these environments and to take care of them. So it's kind of complicated. And it was often, the data lake was often a silo, not necessarily well integrated with the warehouse. And oftentimes these are two very different teams working on it. One team working on the warehouse, another team working on the data lake. Now, for Oracle, we introduced something called Big Data SQL. And the goal for Big Data SQL is to help try to solve at least part of this problem, right? Allowing you to analyze data across your warehouse, and your data lake. So you basically could run a query that would then span the warehouse and the data lake, and to be able to do that at scale. We distribute processing to the data lake, data local processing, all this good stuff, right? And the good thing too is that you could use your existing applications, right? They just worked. Your applications didn't necessarily need to know if the data was coming from the warehouse or the data was coming from the data lake. So this is great, right? You now have like an environment where you can query across your data sets. If your applications are using Oracle advanced security like virtual private databases or redaction or whatever that may be. It just worked, right? You could do that same thing over data in your data lake and keep that data safe. So it was great. Big Data SQL helps partially solves the problem. Doesn't necessarily solve the challenges of maintaining a data lake, but it solved a lot of the analytics challenges from a relational standpoint. This brings us now to the Lakehouse, right? Which frankly the Lakehouse really requires a new cloud-based infrastructure. And the goal of the Lakehouse is to take the best of the warehouse and the best of Hadoop, those architectures, right? But leaving behind much of the complications, right? And the complexity. And most importantly, it breaks down silos, right? So it enables a much more seamless integration between the data lake and the warehouse. And that's exactly what we're going to be focusing on today, that integration. The other thing is that it's also dramatically, the beauty of the cloud is it dramatically reduces your costs, right? Because you only end up paying for what you really need. Now, one other thing I'd like to say, you may hear some barking in the background. I'm joined here with my team of dogs who tend to like to start barking in the middle of presentations. So apologies for that up front. So let's start by taking a look at a customer. One of our customers who's taking advantage of really the Lakehouse on Oracle Cloud, and it's CERN. CERN really is a perfect example of highlighting the strengths of both the data warehousing and the data lake platforms. So CERN, if you don't know, they have a 17-mile long particle accelerator that's buried underground. And they are on a quest to discover new particles that will help them understand particle physics. So for them, their science platform needs to be extremely well managed, right? The reliability of their control data and the speed that they can gain insights from that are really crucial to the science that's taking place there. If they have an unplanned repair, it's incredibly expensive. It takes multiple weeks to cycle it down and to bring it back up and to repair it. So, this is an incredibly advanced IoT solution. They have a complex mix of accelerators and detectors that persist and analyze data from more than 2 million signals. And the logged IoT data is measured in petabytes. So what they've done is they're storing that raw data in the data lake. And then it's transformed and it's loaded into Autonomous Data Warehouse. And what they do is they use our machine learning capabilities in the database and machine learning models to score that data and to predict potential maintenance issues, which is just critical for them to help manage their projects. There's a lot of other use case profiles, right? Compliance and archive. This is really just pure cost savings. You want to be able to keep a rich set of history, maybe 10 years of history for different types of one-off queries that you might get from regulators. So, do you want to keep all of that data in your data warehouse, or do you want to be able to offload that into an active archive, right, into the object store, and then be able to just access it infrequently and on demand, right? And meanwhile, while that data, what's nice here is that as the data that's in that data lake, sure, it's accessible to the database, but it's also accessible to any other processes that are running on your data lake. It's stored in an open format, Parquet, CSV, ORC, whatever, Avro, whatever format you want. The database accesses that data. Your Spark processing may access that same data as well for different types of analytics. The other is extending the data lake, the warehouse to the data lake. And this is exactly what CERN is doing today, right? Now, CERN is actually going through a loading process, but there's also the ability to do this without necessarily loading the data into the database, but you just access that data dynamically when you need it, right? So you run a query, maybe you have some new data that's landed in a landing zone. Perhaps that could help in, maybe it's not certified, right? Maybe this data is not necessarily curated in gold, but perhaps it can be used to help inform marketing campaigns or different types of data science activities. So having the database be able to extend and use that data in a really agile way without having to load it, just query it in a place and blend that data with data in your warehouse really enables much richer types of analytics, and frankly, being able to do that quickly and easily without necessarily having to go through a data approval process and loading process, et cetera. The last case that we're seeing with a lot of customers too is multi-cloud. And one of our questions, our poll questions, refers to that, right? In that case, making it very simple to gain access to that data, whether it's in AWS or Azure or other sources, query that data in place, but oftentimes really loading that data into the data warehouse to be able to analyze your information. Now, importantly, look, use any tool, right? You may want to use Analytics Cloud, Tableau, Notebooks, Python, REST APIs, whatever it may be, right? At the end of the day, every tool supports Oracle database, right? They all can connect to the database. They all support Oracle SQL. When you're running these queries against these sources, they appear that the sources in the data lake from the data warehouse, they appear like any other data, right? And you can just query that data seamlessly. So, when we kind of up-level this and we look at, well, what is this Lakehouse, right? And what are the core components? Let's drill down a little bit. It starts with, you have, I'll start here with on the bottom left, right? You have managed open source services, right? Services like Big Data Service, which is a managed Hadoop-based service, or Spark with Dataflow, right? So Spark, Dataflow is a managed Spark-based service. So you have, or streaming, you have different types of open source services that will be a core part of that data lake used for processing the data and analyzing that data. Data integration is important for orchestrating your workflows, right? You're moving data, transforming it, extracting it, transforming it, loading it from a landing zone into perhaps into a curated zone, or putting that into the data warehouse, right? For trusted analyses. Now, what we're really going to be focusing on are these three parts, right? So, the data lake is capturing data in an object store, right? And the beauty of the object store is you could think about it as being like a limitless, inexpensive file store, right? And you can capture any type of data on there. It could be images. It could be CSV files or Parquet files, right? At the end of the day, just think about it as being a file system with folders, right? That's what it is. And it's infinite, right? It stores as much information there as you want. You don't really need to manage it at all. Now, oftentimes the data lake, it can contain data sets that are of unknown value, right? You just load some new data sets that you want to kind of try out, see if they have value, see if they help inform your analytics. It may be sparse data sets. So, if you think about CERN, look at all the signals that they're capturing. Well, those detailed signals are very sparse, right, in terms of information value. When you look at it in totality, and then you start looking at trends, and you can see, these types of events are predictors to a potential failure. That's when things become kind of interesting. But it is very information sparse. The data catalog is a critical component here. And this is really frankly, this is a service that's, we've had for a year or two at Oracle, and it is such an important part of this solution, right? It is the centralized metadata store for the unstructured files that are in your data lake. And frankly, it's also harvesting other sources as well. But, in the case of the data lake, like I said, they're just a bunch of files, right? So what you really need to do is make those files meaningful. How do you derive technical metadata from them, right? Well, this CSV file actually has a customer ID column, social security number, blah, blah, blah. What are the meaning? What's the schema? So Hadoop, big data or processing is often been referred to as schema on read, right? You load files into these stores, and then the reader of the solution determines what the schema is, unlike a table, which has columns and data types, et cetera, that you load data into. So the data catalog says, well, look, we're going to harvest this source and derive that technical metadata, right? Like the columns and those data types. And then provide a business semantic to it, provide a business context. So, this file, yes, it contains customer data. It was last updated on Friday. It's bronze, not yet certified, but it can be used for analytics, right? So these are the types of things that the catalog is not, it's looking at that data, it's deriving business context from that data, and it helps you govern and understand the information across your data estate, including the data warehouse. It'll harvest the data warehouse. It'll harvest, Hive and Kafka and SQL Server and DB2 and other databases as well. And finally, you have the data warehouse, right? And the data warehouse is the store that is generally used to help run the business, right? It contains curated, trusted data that's used by hundreds of users, thousands of users that are expecting fast, consistent query performance. So it's this integration that we are going to be focusing on. And what we're doing with Autonomous Database is making it easier to integrate, and frankly, not just Autonomous Database, but across that stack, is to now offer capabilities that simplify. I'll break it into two broad categories. The first on the left is simplify management and understand those data sources using the data catalog. That is a central metadata store, and Autonomous Database will use that metadata store seamlessly. So from a management perspective, data catalog scans the sources, it derives that technical metadata, and then it shares that metadata with Autonomous Database. So now Autonomous Database can access that data lake without having to do any type of access management, meaning your tables are automatically defined. Your external schemas are automatically defined. So now that you've had access, now that you've linked your tables in your data warehouse to the data lake, now query them at scale, right? Run queries against those sources like you would any other without you needing to do anything in terms of management. If you think about Big Data SQL, we distributed processing. We had scale out processing by pushing the processing down to the Hadoop cluster. Well, we're doing something very similar here, right? Where we have numerous performance features within Autonomous Database that helps you scale out queries against the object store. And because this is Autonomous Database, there's nothing that you should have to do to manage that scale out. Autonomous Database manages that scale out for you. All right, now, data catalog is likely new to many of you, unless you dialed into some, Abhiram from product management and data catalog has presented a few times on OCI Data Catalog. It's often referred to as the spotlight for OCI. And what it does, and I kind of described this before, but specifically what it does is and I'm going to demonstrate this too, it helps you discover and understand your available data, right? And it starts with you create what's called a data asset. And a data asset is a connection to a source, like an object store. Once you've made that connection to that object store, you use Data Catalog to harvest that source, right? And as I mentioned, it can harvest object store, Hive, Kafka. We're going to focus on the object store today, but it can also harvest Oracle database and non-Oracle databases. It also can harvest the usage of that data through Analytics Cloud, right? So you can go from all the way down to the data lake, all the way up through the, basically from storage to glass, right? And understand how the data is being used. Now, once that data is harvested, you can curate it, right? So in Data Catalog, you define the business glossaries and business terms, and you annotate these assets that you've harvested, like object store, and say, yeah, well, this is actually a customer ID field that, is, and here's the terms that we associated with that customer ID field, and provide context and meaning for that. And by the way, that customer ID field is used by many other assets or many other entities within your catalog. So you can use tagging and business glossaries, and as you harvest that data, it will even recommend what it thinks that this field may be, right? And so you can easily associate newly acquired data with your glossaries and with your categories and terms. Once you've harvested and curated that data, now you have a terrific collaborative environment that allows people to search and find the data assets and the meaning of your data, right? You search based on names, based on terms, custom properties, tags, whatever, right? It has a very rich search capability that helps you find the data assets and understand the meaning of that data. So graphically, right, you have your object store, you go through the data catalog to harvest your sources, manage that business glossary, etc. So now you have the data catalog with all of that information about the data that's in your object store. It's now the source of truth, right? You can go to this one place and actually have a business context and understand the technical metadata that's within your object store. You've turned a pile of files into something that has meaning, right? That's what's happening right here. The next step is to actually connect. You say, okay, autonomous database, connect to and maybe you're multiple autonomous databases sharing this same data catalog. So you connect to your autonomous database to that data catalog. And that metadata that's been harvested from the data catalog will be synchronized with autonomous database. What does that synchronization mean? Well, you will see as part of the sync process what we call fully managed external schemas defined, right? These are schemas that are literally a reflection, and within those schemas you have tables, external tables that are pointing to your data sources. The metadata informs the definition of those tables that have been defined, right? So you end up with fully managed schemas and fully managed tables within those schemas, and the source of the definitions are the data catalog. There's no management required. And frankly, we don't even let you change the definition of these tables within Autonomous Database. You can always define tables in your own schema, and that's fine. And if you define an external table in your own schema and you want to name it what you want, change the columns, the data, it's all yours, right? You can do whatever you want. Here, this is the centralized metadata store. And if you change anything, that will then be reflected in Autonomous Database. So this is the source of truth. And you have your Autonomous Database, or Autonomous Databases. Let's say you add a table in the data catalog, and you have 4 Autonomous Databases sharing that one data catalog. They will now have access to that same table that was just added to your data catalog. Nothing that needs to happen here. It would be automatically synced. It's also secure, right? You then need to give query access. You need to be able to allow people to select from that data. And once you do it, you can then query that data at scale using whatever tool that you want, right? Run Oracle SQL against Autonomous Database. And when you run that query, Autonomous Database, data catalog is actually out of the picture at this point. Autonomous Database will go directly against the object store and query that data at scale. So let's peel back the onion a bit more, right? When you look at this process, right, and you look at an object store, as I mentioned, it's just a pile of files, right? You have folders and files. And if you look at this, right, you go, oh, okay, I have customer information, I have customer sales, etc. Now, what you define the folders and you upload the files, and the files could be of any type. Now, it's schema on read. You apply the definition of the table on top of these files, right? So object store is just a way of capturing information. So in data catalog, you're going to go in and say, well, given that you can store data in different ways, in different formats, in different folder structures, you first tell data catalog, this is how I'm organizing my data lake, right? And there's pre-built flavors, like it says, hey, are you using Hive style? Are you using, it has like example ways that are common ways that you'll store data in a data lake, right? So you specify, yeah, this is the way I am capturing information in my data lake. And then it goes through that harvest process. So you pick, hey, I'm going to harvest the gold zone and the landing zone. After you harvest it, that technical metadata is automatically derived, right? So for customer, for example, like you harvested that customer folder and it said, oh, okay, by the way, when we do this, files within that folder should have the same schema, right? There's no magic here. And the files, it looks at these files and goes, oh, okay, well, you got a first name, a full, the gender, household size, etc. These are all the attributes and the data types that we're deriving this technical metadata from that source. And then once it's been harvested and you've defined that technical metadata has been derived, you use data catalog then to apply a business definition to that. So we have an income level here. What does income level mean? Well, it's a range in thousands of dollars as declared by the customer. And how do they get that information? Well, it's coming from an application form when they signed up, right? This is the type of thing where you go from a file to what is the actual meaning of this information, and then say, okay, now I've collected all this information and I want to search for it. So I'm going to search for assets based on a range of different criteria, right? So I'm going to find everything that has to do with customer, and we'll want to understand the meaning in its context. Now that I've captured all of this information, I can now go into Autonomous Database and start running queries, frankly, in two ways. One, I can actually query the data catalog itself, right? To say, hey, what are my folders that are in the data catalog, and how are they mapping to database tables, right? So these database tables can now query data that's in the object store based on this information. And within Autonomous Database, we can query the data catalog and say, hey, I want to find everything in data catalog that has to do with customer, where the description has customer in the name or the display name or the business name, and you get the results. And when you get those results, again, how those entities map to Oracle database tables. At which point, go crazy, right? You now start running your queries. You're correlating information that's in your data lake with data that's in your data warehouse, and you use your tools of choice, right? The applications that you're running don't even know that data is coming from the data lake. Data could be coming from either. And if you need to safeguard data, if you want to redact social security number or other personally identifiable information, go for it, right? That's all possible because you have Oracle security at your disposal. And you also have the full power of Oracle SQL, right? So, you may have weblogs, right, in your data lake. Well, wouldn't it be nice to turn the sequence of clicks into sessions, right? User sessions, and how are people navigating the site, and where are they stuck? Why aren't we converting that session into a sale of our products, right? Use things like SQL pattern matching to be able to. You could write code, right? You could write code to sessionize that weblog and turn all those clicks into sessions. Or you can write a query, right? And you can iterate on that query. And you can do that from within a SQL developer tool, right? You don't have to submit jobs and iterate. Just start running queries and iterate with just in seconds, right? So it's a much more productive environment. You have when you can do things through SQL, right? You don't have to fall off a complexity cliff. Just use your existing tools, use your existing applications. The nice thing about having the richest SQL language out there is that you can apply that now across all your data. And you can then also scale out your queries, right? So this part is actually in what we call limited availability. So if you want to take advantage of querying data at scale, just you let Oracle know, and we'll enable your autonomous database for this. So there are certain things actually that are available today in autonomous database. Things like partitioning, right? You want to be able to partition. These data sets can be really large, and oftentimes these really large data sets in Object Store are partitioned. So apply Oracle partitioning over those data sets. So you get things like partition pruning. It's all about eliminating scans, right? Don't read data that you don't need to read, right? That's a big part of this. Autonomous database also has dynamic auto scaling, right? There's two types of auto scaling. There's the database auto scaling, which will allow you to use more database CPUs when scaling out. There's also a specialized processing that is used by scale out for querying the object store at scale. So that is kind of like, you think about for those of you who know Exadata and Smart Scan, this is really Smart Scan for the data lake, right? It uses separate compute that will scan, filter, aggregate data, and bring the results back to the database. And this separate compute is fully managed by Autonomous Database, right? There's nothing that you need to do. You run a query and it just uses this transparently. If you have a small data set, it doesn't need to use it, right? You don't bother. It doesn't bother to use the auto scale. And that auto scale, it's literally just used for the lifetime of the query itself, right? So that's the only thing that you need to pay for is the query for the life, the consumption for the life of that query. The other key thing too is that it reduces the impact on your database workloads. So let's take a look at this, right? I've been talking for a while. I didn't think I was going to talk this long. So let's take a look at how all of this works. And hopefully I haven't been timed out, and I haven't been. Oh, that's cool. What I'm starting with here is I'm actually in one of our notebooks that's part of Autonomous Database. We're using a machine learning notebook because it's got a really nice SQL interface, frankly, to be able to not just run machine learning algorithms, but also you can run queries from within here as well. And in this case, we have live labs that are called based on the company called Oracle Movie Stream, which is an online movie streaming site. And for Movie Stream, think about them as being similar to a Netflix, right? We're looking at sales in our warehouse that Movie Stream has. So Movie Stream has a data warehouse and a data lake. And they've in their data warehouse, they have some core information about their customers, right? So here I've just run a query that's saying, hey, let's look at my top sales by city. And if I scroll down, you'll notice that here you can see it's New York City and LA and blah, blah. We have all this geographic information or contact information about our customers. We know how long they've been a customer, where they are. So, we could do things like spatial type of queries, etc. But it's all kind of contact details. I don't have demographic information about them in my warehouse. So what I want to do is I kind of want to get a flavor, a better understanding of who my customers are, right? Let's get a customer, better understand our customers. Let's get a better customer profile. So it turns out that I have my data lake, right? And in my data lake, this is kind of what it looks like. I have my gold zone, right? Okay. That's a bummer. So let me just log in. This is how you log into Oracle Cloud. And we'll go to our object store. Bucket. Let me go to my buckets. Okay, now we'll go to our gold zone. And in our gold zone, we have our customer contact information. This is the source for the warehouse. I have customer sales information. And if you notice, customer sales is broken out by, these are partitions, customer sales by month. And this is actually in Parquet format. Now and I have movie information and genre information. I also have what's called a landing zone. The landing zone has other types of information as well. This stuff, the data here, like a customer extension is a file that has more information about my customers. But I have weather data, pizza location. This data is not necessarily verified. It's not necessarily completely clean and curated, but it's useful, right? I wouldn't want to report to regulators based on this information, but it's helpful for analytics. Like data doesn't necessarily need to be perfect, right? For analytics all the time. You want as good a data as you can get. It really depends on the type of analytics that you want to do. Right. So this data, I have data in the landing zone, and I also have data in my gold zone. But again, here it's just really a pile of files. Like, what is the meaning of these files? Well, this is where data catalog helps, right? And in data catalog, you create what's called a data asset. In this case, I've created a data asset called the data lake, and I could create new data assets, right? So I have a data lake asset. I can create an asset over Hive, Autonomous, database, whether it's ADW or ATP, DB2, Kafka, lots of different sources, right? So you create this asset. In this case, I created an asset called the Data Lake. And this one is coming from the object store. And by the way, I tagged it with Data Lake. I've also assigned a file name pattern. And this file name pattern is saying, for this Data Lake, this is how my buckets are organized. It's actually a folder-based organization, right? The file pattern is very important because now when I go here and I say, I want to harvest this object store, you specify that, okay, I'm going to connect to it. I'm going to use this file name pattern as part of the harvest, and you could use different ones, even for different harvests. And you specify, okay, I'm going to harvest my gold zone and my landing zone next, and create a job. And this job can be, in this case, it's an incremental job. It can also be scheduled, right, to run. Well, as a result of that job, right, what you will get, and we'll now browse our data assets, are what we call, so we just harvested the data lake. If I drill into that, there was a bucket called Movie Stream Sandbox. There was one called Gold, Movie Stream Gold, and we changed the name of it, and we said, hey, we're going to give a business name called Gold to that, right? So that's this gold zone here in the object store. So I have this gold zone. I have my landing zone. I can drill down into landing where I have my customer contact information, my customer segment information, movie information, weather. And if I look at my customer contact, you can see it has all these different attributes associated, right? And if I look at a summary of it too, you'll notice that there are, you have your business glossary, and you can we've linked these terms to this table already, right? Like the address line, etc. I can also tag my data here as well, right? And say, yeah, this is part of my data lake, or create new tags, whatever. But that helps in the searching process. So I've come in here, right? And I've gone through this process now of harvesting. I've derived all this metadata. And now what I want to do is make use of it. Like, okay, I remember I'm back here in machine learning. I have this information. I want to better understand my customer profiles. Well, how do I do that? Let's search for objects that have to do with customer. And I want to look at things from my object store. And I can now start looking at this and say, oh, okay, I have this. And you can keep going, right? Keep refining your searches. Well, I have this customer extension data. It's customer demographic details from a third party. It's approved for analytic use. It's silver. The source was Customer Q's LLC, a third party. So I got this third party data from to get these customer demographics. Okay, that's pretty cool. This is customer extension is something that I think I'm going to want to take advantage of. Let's go back now to machine learning. And from within machine learning, I can say, well, how do I access that table from Autonomous Database? So let's run a query. And the query that I'm running here is I'm going to select the folder, the display name, and from the business name. That's coming from the data catalog, right? So we have our assets coming from, or here, this is coming from data catalog. And then I also have how do these map to our Oracle database schemas. So in my landing zone, here's the result of the query. In my landing zone, I have that customer extension. The name of the file in the database is called dcat, is stored in a fully managed schema called dcat obj landing, and the name of it is customer extension. That's the name of the table. I also have customer segmentation data available here. So At which point I can now say, well, let's just start running some queries against, I have my customer segments. I also have my customer demographic information. This happens to come from the object store via the data catalog metadata, right? So now I have their last name, their first name, their commute distance, their education, gender, right? I have all this information now about customers that aren't necessarily loaded into the database, but they're now accessible to Autonomous Database. And we're leveraging a single metadata store that's turned files into something more meaningful that I can now understand and use. So, yes, would I like to keep going? For example, now I want to break out my sales by customer profile. Oh, sorry, I just hit run on the markdown. Now I want to see the actual query itself, or run that query, and here it is. So now I'm going to look at my customer short name, or the customer segment, the genres that they like. I'm pulling that from the data lake, and I'm combining that with data that's in my data warehouse, right? So now I can see more interesting information that double income, no kids, folks, they really like dramas. If you look at divorced and widowed people, more interested in comedies, while folks who are under 22, like here's my different customer segments that our data scientists created based on my customer profiles. They uploaded that into the object store, into the data lake, and we're just making use of those insights that my data scientists created these segments. I'm combining that with the customer attributes to be able to understand my sales better. And if I want to look at things like, hey, what customers are at risk? We're going to run recency, frequency, and monetary analysis, right? So this query is actually going to go off and say, look, I'm going to bucket my customers into 5 groupings based on revenue, based on the last time they came to our site, and how frequently they've been coming to our site. So you have these 5 buckets. And if I look at this now, I'm saying, hey, I want to find those who are in my top level buckets, 4 and 5. These are actually big spenders. So I have these 5 quintiles of my customers. Number 5 are big spenders. Quintile number 1, don't spend a lot. If they're in recency is less than or equal to 2, that means if they're at 1, they haven't been to our site in a while, right? And number 5, they're active users. So these are customers and a profile of these customers that are able to tell us, yeah, these are important customers who had been big spenders, but they've kind of disappeared. So I wanted to kind of wrap up here now, and we have more questions for you as well. But the goal, the key takeaways are, look, we're trying to make it easier than ever to get value from all of your data by making them more accessible, right? And do it in a productive way, right? Hadoop is very powerful. Hadoop is pretty complicated. The Lakehouse now has said, okay, let's take the best of that, of Hadoop and the data warehouse, and bring it all together and make it easy and provide an agile environment to be able to access and analyze all of your data. And, finally, look, we have links, and Ken is going to drop these links into the chat so you can access them. We have live labs for you to follow up on if you want to start using this yourself. We also have some poll questions for you. So it would be great to get your feedback on what you think of this session. What you think of, is this something that you'd be interested in using? Is this make sense? Like, is this a platform that is something that you feel like your organization could really take advantage of? So please, give us some feedback. And why don't we have a few more questions. Hopefully, Alexi, I don't know if people have been asking a lot of questions during the session itself, but any questions, bring them our way. And I know we're at the top of the hour and people probably need to go to their next meeting or whatever. Kenna, any you want to wrap up here?
Yeah, I just want to say thank you so much to you, Marty, for coming back and delving into this. And thank you, Alexi. I saw Q&As popping up and I saw Alexi answering them. So I know that there were some questions and answers going under the surface here as we went. And I encourage anyone who's still stuck around here, if you haven't filled out that poll, please do. And if you have questions that come up after the fact, if you go like play with the live lab and then you have questions after that or something like that, always feel free to reach out, go to the Cloud Customer Connect forums and post your questions. We're always curious to know how you're using the products and services and how we can help you use them even better. So definitely feel free to reach out to myself and I can orient you to the right people to get those questions answered if you run into those in the future. So thank you so much, Marty, for joining us. Thank you, Alexi, for doing the Q&A there. And come back and join us for more events in the future. We're excited to have you all. Have a good day, everybody.
Thank you, everybody.